Hello, welcome back. Last time I did Exposure Mask Viewer, and though my head felt hazy, I eventually got it done with my original plan, so I was in the right place. I just could not tell until I saw the program working. So I had a think about this a little bit ago in the shower, had some shower thoughts about dividing numbers in this instruction set, and realized it wouldn't actually be too hard. I think I understand how to do it now, so once I get to this, it should not be a big deal. Histogram viewer, let's go here. Oh, also, I had another look at the instruction manual just to see about stuff that I hadn't used. I've used neg once. I remember it exists. Haven't had an occasion much. Still have not had any need for any and last, so I should keep those in mind. I used jrow once. It was cool. I'll remember it exists. Not sure when this form would be useful, but this form can be, certainly. And then I noticed there's a jnz. I wanted this a few times and just didn't realize, like, reading around Jez, Jugs, and Jills, I forgot, didn't realize there was a fourth one. So Jins is here too. Remember that. Cool. So histogram viewer. Read a value from in. Draw a line that many units long to the right of the previous line drawn. Oh, that sounds easier than the exposure mask viewer. Now it wants it vertical, which is fine. Okay, so 8, 10, 10, 10, 13. This sounds much easier. 20, the large number of perceiving devices arranged into an array could be 7.0 towards something and collapse its /wave function. Thus 5e makia arkung it real. Okay, so what does that say in English? The large number of perceiving devices arranged into an array could be pointing towards something and collapse its wave function, thusly making it real. I don't understand that any more than the garbled version. Okay, so here's image, here's in. So this would be much less annoying if I could do it horizontally, but it's going to be vertical, so that's fine. So you need to, okay, so remind me the image modules API. Random access memory node, not implemented, interactive debugger, visualization module. Right, so coordinates, the size is 18 characters tall. Okay. So somewhere in here is going to be a counter of a row counter. So I think I can just have like this guy be the row counter. So yeah, you just read from here whenever you want to know which row you're doing. You're going to store the row. I might end up regretting that, but that's my first thought. So that's how this will start on every column. So then you need to know, so then I can just do this. So you start at the bottom. Oh, and you're going to plot 1 pixel at a time, so I can't just keep on putting those. So I have to do all 4 for each plot. Okay, so this is going to be a slow program since it has to go vertically. Got to go bottom up. Okay, so this is going to start at 30, but I need to subtract as many times as... Okay. Going at this backward, that's fine. And then it's 3 for white, and then -1 to terminate. And then sub1, swap sub1, something like that. So start at 30. Somehow your back needs to be filled with the number of... Oh, and you need to swap again. Oh, and you need to swap it. Okay. Okay. This is most of this program, I think. I just need to get this value into your back initially, right? Okay. Like that, right? Is that a complete program already? No, what the heck did I do? Well, that's not right. What have I done? Not the right thing. You are increasing. Okay, right, so you need to reset. Of course you do. Well, no, you don't. No. Of course. So the problem here is that I'm reading this way too often. That's the only thing. Is it the only thing? Maybe. Maybe. Why did it not start in this column then? So you get 8. That goes into back. This program's not finished because you're reading that too frequently, of course. There are ways I can handle this. I am out of registers here, so you can't use that, but that's fine. Again, if I were doing this in a horizontal orientation, I could get away with this trick, I think, because I would only need to read that once, then draw a whole row of pixels, but it had to be vertical. Okay, so yeah, 0 goes down. 0 should be this column. Why didn't I see a pixel drawn in that column? AC is 30. Yes, that makes sense. Then you draw that color. Oh, because I want to start at 29, of course. So now I should see that, right? No? Why are you all the way up there? Oh, it's 18. My mistake. I was reading the width instead of the height, of course. Okay, so it's 18. But it's actually 17 because I want to start at the... Okay, so it wraps around? Is that what you're telling me? There, okay. So I have a pixel here. Right. So it's 0 through 17. 18 values. All right. But then you go all the way up there... I think you're swapping wrong somehow. So you move up into AC, swap. So you get the 8. Then 17 into AC. Read this. This part's broken, but that's fine. Let's not worry about that yet. Then the 17 you moved in. Yep, that's fine. The color, and then terminate. Then you subtract 1 from this value, swap it into there, and then sub 1 and say, what the heck is this? What? What am I doing here? Hold on, what do I read from there? I read the number of... Oh, right. No, that makes sense. Right, I want to go to the loop on... Okay, this is fine. It's not. I can do something dumb like this. That'll be real inefficient. It should work, though. Like just extra swaps so that the swap will be in the right place when I jump to the loop, because I need to jump on a value that's going to go into back. Feels like there's a smarter way to do that, but let's see how it does. Okay, so that's much better. All right, so if I fix this problem, I think this will work. Don't like this inefficiency, but it just seemed like the simplest way to solve that problem. This program is done, kind of, as long as you can have your thing communicated the way you need to. All right, so... Ooh, this might be a use for a no-op here, I'm spotting. Because I want some information to flow from... I need information to flow into this prior to you issuing this read. So you might need to slow down a little bit on reporting your information to this until a number of instructions equal to the number that this needs to increment its thing has happened, because I'm going to send... I'm going to send this on And here's one instruction that needs to execute before you read this value, because you need to get a new value here. Yeah, but I mean, you can't just be blocked listening to this. Okay, so what does this actually mean? And why the heck am I way over here instead of here? This would be more comfortable. This would be a lot more comfortable. That makes more sense. It's fine though, not going to worry about it yet. Alright, so the only problem is my column index. When do I advance that? Why couldn't you just keep track of it? I don't need this additional thingy here. Do I? Alright, so you need a... Right, okay, so this is back to the same thing with, like, I want to signal the number of times I'm going to read that, which is fine. Yeah, so that's how this would work. Right, of course. All right, so let me do what I was thinking about with that previous puzzle. This stuff will still happen, just not yet. Okay, so this thing is going to listen for the number of... this inefficiency is really bothering me. I'm gonna change it. Because it's just silly to have it do it this way. And this lines up better with what I wanted to do with the whole, like, having this arrive before this arrives, you know. And if I'm doing that, I want it in this order. Okay, so move left, down, move up, down, right, move up, back. Okay, so when you receive this number, that's the number of times to report this value before adding 1. So, I'm going to swap. I'm going to sub 1. No, wait, hang on. Yes, sub 1. Jules add. Sure. Can I get away with this having the same name as a... Well, sure, it's syntactically distinguishable. Like, you can tell that I'm not trying to add here, I'm not trying to add here, so just because that's a keyword doesn't mean I can't also use it as a label. That should be fine. Okay, so I'm going to move back... Right. No, what? No. Wait, hold on. Where am I? What am I doing? So you receive an 8. You store it in back. Then you subtract 1 from ac. What? No. So you're going to save. So sub 1 from this. No, wait. No, you just start at 0 at init time. Right, okay. I have too many versions of a half-formed version of this program in my head. I'm going to start over. I can't reconcile them that easily. Okay. I'm going to receive an 8. Then that many times I am going to send the current accumulated value, which will start at 0. So I sub 1 so that it's 7. If it was supposed to be 0 times, then I... there, let's use a nice descriptive label. So you're going to do something there. Let's not worry about what that something is yet. I think I want to swap, and then swap, and then okay, I think that's all. Lot of extraneous swaps both in this program and this one. Not extraneous, but like possibly avoidable. Like especially these. But I'm not going to worry about it yet. Let's see if this works. Is this program done? That looks pretty good. That looks pretty good. That looks really good. Okay, great. I did it. Yeah, like I said, this is not too terribly complicated a program. I have written a cycle inefficient version of it. My nodes are not the worst. I'm sure you could do this with one fewer nodes if you wanted. You could do it with a lot fewer swaps, almost certainly. Okay, so that succeeds. Node count is average, instruction count's a little higher, cycle count. Well, a lot of people did this solution. So cool. All right. Well, hey, I'm happy with that. Image console sandbox. Right. So this gets a larger thingy. Whoa, what are those? What? I can't click them. I don't understand. This is a number pad layout, but what? Did this have something like that? It has a console. I mean, this is a sandbox, so there's no anything to solve here. What? Is there a way to type in this? I just want to understand, that's all. Stack memory node, console. Okay, so I run it to populate that a bit, and then I can, I don't know, it's weird. Seven, 8. I don't know what's going on. Not going to worry about it too much. That's fine. Okay, let's go to signal window filter. Not going to commit to getting this done today since I already did one puzzle, but I'll take a look. Read values from in. Write the sum of the last 3 values to out.3 and the sum of the last 5 values to out.5. Assume prior in values are 0. That doesn't sound super hard. I get 2 stacks. Yes, this machine was built to be used. Something. To observe something. Not just anything like a camera, something specific. Its memory still contains the last thing it saw. Yeah, last thing it saw at this point is what you typed into it, kinda. All right. Read values from in. Write the sum of the last 3 and the sum of the last 5 to out.5. So you're saying... Yeah, so this is a moving window, yeah, signal window filter. Moving window of values. So it's not like read 3, then write the sum of those, then read 3 more, then write the sum of those, and do the same for 5. No, it's just the last that many that were... Okay. Almost certain that I could do it without these stack memory nodes. I should just keep in mind that I can use these tools if it seems more convenient to do so. Yeah, I'd bet. No, I wouldn't. I don't bet. I would very, very strongly suspect that 4-node solutions for this exist. I will not implement one today, but I very strongly suspect they exist. So let's see. This requires storage of how many values? 5? 6, 7? A bunch. So let's see, it's a stack memory node. So it's a LIFO. I could have a 3 stack and a 5 stack, maybe. Would that make sense? I'd kind of end up with some crossed wires here if I did that, so I'd have to deal with that. It's possible this is where any and last would come in. Yeah, like if you were a wire crosser and you were listening for any traffic and then kept sending to the... Okay, that might be a thing I might need to do. But let's just sort of think of the logic of this. In a high-level language, like all of these problems, this would be very easy, but this is a low-level language. So... the outputters... Let's see, I'm trying to think if I could... I'm trying to think of cheats like keeping a 3-back and a 5-back value and then subtracting those rather than actually storing the intermediate ones. I think that's probably a good idea. So that would cut my storage down significantly. I would only need 2 prior values. Then I could just add the new ones coming in and have the prior values like propagate through the system at the appropriate time. Yes. Yes, I like... Oh, but that does mean I still need to keep the prior values around somewhere. Right? Yeah, because I can't lose a value. I need to subtract... Okay. Okay. This is fascinating. I'm going to think for a moment and see if I come up with anything brilliant. Alright, so here's my half-formed idea. Let me see if talking through it will help it become fully formed. So the vision I have in my head is of one of these stack memory nodes getting the last 5 values from this. So it'd be, 0, 0, 0, 0, 11. Then in the next iteration it'd be 0, 0, 0, 11, 77. So it would contain 5 values in it. This guy right here, the one in between, would pull everything out of this stack. While it pulls it out, it would write those values into this to preserve the values. Take the first and third that it pulled. No, the third and fifth that it pulled, since it's LIFO. So yeah, third and fifth. Pass those values on to these guys, which are accumulating stuff. Then once it's done filtering through those, it pulls the values back out of this, inserts all of them in here again, while also receiving a new value here. Okay, something like that. Something like that. I think you are going to need to, like, initialize this with 5 zeros and then terminate your thing forever? Is there a terminate command? I mean, I could just, like... Yeah, I could either go to a NOP or, like... What is it? JRow 0, I think, would be? Yeah, JRow 0 is how I terminate. Fascinating. There's an actual use for that, possibly. If I did want to initialize this with 5 zeros and then terminate forever. Now, that would use this unit. Maybe I'd be better off doing... I don't know, this is going to be a complicated program if I want to do all that. Oh yeah, you're not going to have enough space for this probably. Oh boy. Okay, I don't know if this is a good idea. So the questions are, how do I initialize everything? And how do you do your job? Like, the concept's not super complicated, and again, it's kind of hazy. So hang on. Let's think of this as if we're in the middle of it. So you would already have loaded into you 11, 77, 17, 67, 30. So move up ACK. I do that, and I pull out a 30. The 30 is no longer in there. I move it down here. And then I do that again. So I pull out the 67 and move it down there. Oops. Yes, paste. Okay. I guess it had to put in the new line. Sure. So then once you do that, you pass on the 3, sure. So then you do it again, then you do it again, and pass on the 5. This is a lot of repetition. This is why I was sure this program, as I had it like unrolled in my head, would not fit. Easier way to do this. Do that 5 times and have this node filter and just discard the first, second, and fourth values it pulls from this one. So essentially this would be the nil for the first, second, and fourth of these. Okay. Oh. Okay, and then just repeat this, right? Okay. So that still means information has to flow into here, presumably via this route. Then information, some signaling is probably going to happen. You can start with 0, assume the prior values are 0, yes. So then you would be, all right, so information would flow like this. In, then this way, then in here. And then probably, well, no, let's see. Yeah, here, pass a signal along this route, so you will have to both signal and discard some of these, huh? Okay. Because you need to wait to do this until this is filled with all its stuff, right? Probably. Yeah, because otherwise you'll be pulling the things that fill it from here out in the wrong order. Hang on, how do new values come in? This is not done. This is just resetting this to the same state. So 4 times. Yeah, so crossed wires again. Okay, so how does new information flow in here? Well, now hang on. So 30, 67, 17, 77, 11. Then in reverse order, it comes back up. So, so where do I get the new value? So let's say I read it from left. So that's the only possible place you're going to get it from. Okay. Unless I use timing. Oh, I could use timing to have this insert the value while you are empty. I love it. Oh, and I hate it. Some of both, but mostly love it. Okay, cool. So time it carefully such that this value comes in and gets inserted while this has emptied it. Therefore, you don't have to worry about that at all. Great. Other node insert. There's an S there. Other node insert. Okay. This node inserts, and then you do that. So this is a tiny little timing window here. But I mean, I can synchronize it exactly in theory. So I still have to initialize this with 5 zeros. That's fine. I mean, let's, again, think of this fully unrolled. I'll roll it up as necessary first. You need to wait. All right, so left will just give you any signal at all that is ready for you to start. Okay. Not for some amount of time. Sure. Something like that. That's my first inclination here. All right, so you would pretty much just move up, right. You need to send a signal. Send signal when ready, and you need to ferry a lot of stuff around. This is going to be a very busy unit. How done is this? It needs some loop logic, like these need to actually be implemented. You're using your ACK, so I would use back, obviously, and I can definitely do that in fewer instructions than just copy-pasting this 5 times. All right. So how's the logic of this, though? Like, do I have any design flaws here? You start by putting 5 zeros in. You don't need to start with 5 zeros. You can start with 4 zeros and a real thing. Probably. So another thing about synchronization here is this could wait for signals. Like, you'll send a signal down here. Well, no, if you can't wait for signals because you need to know, unless this sends a signal back when it's waiting and then waits for a return. No, I don't want all that logic. I just want to synchronize. Right. Okay. Am I going down just a crazy groundhog hole here? Like, is this just not a rabbit hole? That's the expression. I knew something sounded wrong about that. My mind's in a weird place right now. Am I going down a crazy rabbit hole that doesn't actually lead here? This is why I want to do a high-level logic check before I move on. So these guys... Wait, sub up. Oh, you need to add the most recent number. Okay, right. Okay, so instead of actually writing that out, that sounds approximately right. So right, these guys need to both receive the most recent number and then also receive the however many back to subtract. Okay, that seems reasonable. Do I want you to send on to these guys? Maybe? I don't know. Like, this value definitely needs to go to 3 places. Here, here, and here. For this implementation to work. Okay, so hang on. Again, high-level logic check. How is this? So right, read the input. This needs to go here, here, and here. You are going to start by initializing this with 4 zeros, then moving a real value in there. And then wait, somehow magically synchronize with this. Okay, the next thing that's going to happen is you need to receive a signal. Then that signal needs to come from here. So pass on the signal. Yeah, so you wait for you to move any value. Just a 0 is fine. Somebody gave me a tip to give this like a distinctive value just so I could spot it. Sure, -888. That was the number my finger landed on. So I repeated that number 3 times. This will be a distinctive signal just so I can see it flowing through the thing, and I won't mistake it for something else. I like that idea, so let's do it. So -888 is the signal for this. Could be literally any number, because it's just going to nil. So that kickstarts you. So let's see, we're going to wait 1 instruction, 2 instructions, although actually, how does blocking work? I'm going to have to learn how the timing works. Like, if you're blocked on this, and you're blocked on this, in 1 cycle, does this number make it all the way to here, or does it have to take a cycle to pass through here? I don't know yet. Anyway, So I need an actual loop here. Well, hang on, but I'm doing a high-level logic check. Let's assume this is an actual loop. Right. So after you have signaled this, right, so you're waiting. At the same time, you are emptying this, filling that, and pushing this onto here. One, two, four. Actually, you know, it might not be bad to just have this explicitly unrolled. It's very possible that those 5 instructions, with all the repetition, are going to be the most efficient way to do this. Because it's only 5, and expressing this any other way would probably be less compact. Okay. So assume I was doing that. This should be down. You're going to have to alternatively... Okay, I think this is actually done now for this purpose. Not quite true. How is... Well, you know what? Whoa, come back. You can just pass it on then. Which will make you a little less efficient, but you're already kind of overloaded, so you can take some of the burden. All right, so add most recent. So just repeat that message, because both of you need it. That's your add. Okay. And then you're going to sub up. Right, okay. So this is your read. This is that. This is a repeated thing from there. Is this. Okay. So that has given the addition to both of these. And then this is for this one. It matches up to that. This is for this one. And both of those come from here. Okay, I think this is developing into something good. I one more leveled, but I'm too deep into this to stop now. I think this is a great idea. The only part I'm really worried about is the synchronization here. You have moved that to the right. You need to move it 2 directions. So you're splitting your signal like this. You're repeating your signal twice. Sounds fine. Who's going to be the slower one? I'd like to start this first, I think. Even though it'll be slower on the initial, it'll be slower to read this value than you will on the initial run. All subsequent ones are going to be mostly blocked on this. So this should move things through the system quicker, I think. I'm not actually sure about that. But that's the order I'm going to do it. I think it makes more sense. Okay, so you listen for that and stick it in here. All right, yes, so those are the 3 places this is going. So this information is going where it needs to go. That part is done. Great. You're initialized with 0, so this is all perfectly fine. You'll be subtracting zeros for the first 2, and you'll be subtracting 1s for the first... subtracting zeros for the first 4. But those zeros will, in fact, there'll be these particular zeros. Okay. So, right, this is an unfinished portion. This actually signal, yes, I got that already. So you're signaling with that. Then, oh, is this program finished? It might be. It's very possible that this is already finished. I don't specifically know of anything more you need to do. You're done, you're done, you're done. I'm not using any of my back buffers yet. I'm using stack memory nodes instead. Boy, my node footprint is huge. I'm using all but 2 so far. That's fine. Cycle count's not going to be great. Instruction count's not going to be great. So this is going to be a very inefficient solution. Maybe the cycle count will be good. None of my other statistics will be. Instruction count, especially not with stuff like this. Anyway, not worrying about that. I need a for loop of 5 items. So you're going to use your back buffer here. Move up ACK. Move ACK down, move ACK left. Swap, sub 1. Jugs. Let's see, right, so you do it once, then you subtract, so that means, definitely going to want to minimize this. Because I'm pinched on the lines here. Hey, look what I can do. I can save a line like this. Watch. If I make this 5, that way my signal is also a value that goes in here. It's silly, but it saves me an instruction, so I'll do it. All right, I lose my distinctive signal, but I gain another instruction back. Great. Boy, I love this game. This is so good. So right, this is your iterator variable. Then you put it in back. Then you use ACK for this to ferry data around. Then you do that. Jugs loop. Okay. So then I need... So when that is 0, I want to move 4 into ACK. Swap. Loop 2, move down, up, sub 1, right? Is that program done already? So then timing is the next question. Let me see what this does so far. This is going to shove values into here way too quickly. I have 2 spare instructions here. I might actually be able to just spare a signal for you to do this. If it would be easier, like if you run out of instruction space here and it'd be easier to like send one signal from here to here at a particular time and synchronize that way than to have this wait for like all of these to complete, because that's a bunch of NOPs. But I mean, can't I just... Yeah, you're not even using your register, so all I need to do... Let's not guess. Let me calculate this. Actually, yeah, you won't even NOP. You're going to sub 1. All right, sync is sub 1. Wait, jump loop. Yes, because I don't want to repeat those. Of course. Okay. So the only question is, what is this value? All right, so let me see if I can make an educated guess rather than just run this and let it tell me. I'm going to see if I can actually get this information. So the instruction overhead of U is 1, 2... Ooh, so this is an even number. I might have to insert a NOP here if I have to do an odd number so that that would synchronize. Fascinating. All right. Yeah, because I can't sub and jigs at the same time. All right, so anyway, hopefully you get what I'm saying. I'm not going to explain it further. So then you'll jump loop. So you have an even number plus 1. And then this will already be waiting. I'm going to assume you will keep up with this. You definitely will. So then another instruction. All right. and then that will insert this into here. Okay, all that has to happen right in this spot. So when your instruction pointer is here, yours has to get here in either of those two lines. Okay, so I have a 2 instruction window to synchronize this. All right, so when is the sync gonna start? You'll move 5 down. All right, so your pointer will be here. Here, I'm gonna mark this with a breakpoint. All right, so your pointer is there, while your pointer is waiting here. Okay, so and you are there. Okay, let's assume for the moment, I don't know that this is correct, but I'm trying to make an educated guess. Let's assume that this executes as a full instruction. Yeah, let's assume it takes a cycle to ferry a number from here to here. Okay, so then you have executed that, and you have moved on to this. So then you will still be here. All right, so then these two will proceed. You'll be there. So I already need 1. So then you're going to wind up here as you go here. Okay, and then that's just 3 times 5, so 15 of these divided by 2, so 8 or 7, depending on which way I want to round. I think I want to round that way. Okay, let's say 9. I think 9 is my educated guess. Let's step through this one thing at a time and watch carefully. So no one should do anything whatsoever until this has done its thing. 0, 0, 0, 0, 11. Great. So then start sending that signal. 5, 5, move 9 ACK. I'm watching these two. Is there a... I think there's a... Here we go. This is not the quick reference I wanted. What are my shortcuts for the debugger? I want a keystroke for this. And to tamper, begin, step or pause, F6. All right, so F6. So that I can use my cursor to point at stuff here. All right, so your ACK is 8. All right, so you're... Oh no, why are you moving down? Oh yeah, of course. That takes a cycle. Ooh, so you are 5 instructions, 6 instructions, 7, 8. Whoa, this loop is way bigger than I thought. This number is going to have to increase dramatically. All right, so what we got is 1 extra, 2 extra, and then those other 3 instructions. Okay, so I'm going to just put a stop to this. So what I thought was 3 is actually 8. Okay, so this had 1. So then that's 8 times, so 4. So divide by 2 for the double instruction here, times 5. Okay, so 21. That's 4 times 5. Let's see how this does. So F6. Oh, this works. I'm going to be real happy. This is super cool. All right, so I'm not even watching. I mean, I'm watching, but like, ooh, you finished? You didn't even come close to making it. Hold on, did you? No, you've already moved on to that. Hold on, I missed the, what I was waiting for initially. So back has 5, yes. Swap, sub 1, Jigs loop. Loop, yes. Okay, so you're at 16. Ooh, I need another swap in there. Shoot, it's the same problem that I had before in the last program I did. No, actually, this is more convenient because I can just do this because I already have a swap there. But then my loop is longer. So this becomes 9, so 4.5, okay, so 9 times 5 divided by 2. 9 times 5 is 45, divided by 2 is 22.5, and I'm rounding up, so this just gets... Wait, that doesn't sound right. The numbers I just said are right, but why would I only add 3 to this? That sounds wrong, but let's see how it goes. Okay, so at this point I'm okay with this just telling me what value needs to go in here. Because my educated guess is just running into too many problems. Okay, so I need to see what value this reaches at the point that you step down here. Yeah, okay, so adding that swap means this loop is actually working correctly, because I wasn't when I saw your instruction reach this point, it was because I was not swapping correctly. I got my values mixed up. 11, 0, yeah, okay, so you're getting the contents of that. I wonder if I'm discarding the right one. I don't actually know that for sure yet. I hope I am. Things are happening down here, not going to worry about them yet. Oh, you're already moving your value down, so you're writing some output. Alright, yeah, so back is still 2. You're still at 10. You wrote some output. Great, it's correct. Great. A lot of stuff is happening in parallel. Alright, so you're doing 1 more in this loop. You're doing 6 more in that loop. That sounds approximately right to me. I think you're going to run out too early. I think I'm going to need to add some values to you. Well, no, you're done. You have 5 values in you. I need to subtract 1 from this. 23 is the correct amount. I would land in there perfectly with 23. Do I anyway? No, you've already done that and messed up my value. Also, that needs an extra instruction. But 23 should have been okay. I might want actually 22 because of this extra instruction here. Yeah. Let's do this again. Just see if 23 works. 7, 6, 5, 4, 3, 2, 1, 0. Okay, so you landed there. You're trying to get to where you need to be. Oof, they're both trying to do it simultaneously. Implementation defined. It happened to work, but I didn't like it. If you go a little earlier, I think it'll be better. It happened to go in the order that I wanted, but I did not like relying on that behavior. So yeah, if you go a little bit earlier... Yeah, you're already long since done. Like, it's actually anywhere in here. There's a big range. Oh, so I can subtract a lot from this. Yeah, it's a larger range than... Okay, so how little can I get away with? Hold on, I missed it. Okay, so I want to run for a little while. Okay, so there's that 77. I want to pause right about here. So 4, 3, 2, 1. Alright, so you moved it. I could get away with 19, I think. I could not get away with 18, I think. Oh geez, what did you do? Hold up. Okay, no, I missed my pause button. Okay, so F6. 2, 0. Jig sync. Yes, perfect. You pulled it out. You went there. You're going to put that in, and there's plenty of time before you want to reinsert this. You're going through your loop. Stuff is happening. Oh dear, you're trying to synchronize again. Wait. Why? Why are you here? Shouldn't you be blocked on... Oh no! I don't have blockage because this... The fact that you want to block on output doesn't mean you're going to block on input. Ooh, I have a flaw. You're just going straight back to that. Okay. So that's a very distinct flaw in my plan. I was expecting this to block on you. So I think you actually need to read a value from this. That's fine, I have instruction space. I think this will be correct. So that should synchronize everything, right? You get to 0, you're going to do all that. And then... Yeah, so you already did this. You're waiting for that value to come in, and you are actually waiting now. Great. You're waiting for this. Great. All right, so I at least fixed that flaw. What's the output doing? I see 11. I could just let it run now, because I think it might be done. I just want to see these synchronize a second time. And I don't know if I'm stacking up the values the way I... Why do you have values still in you? What? What happened here? This didn't execute as many times as it was supposed to. So I have an additional problem here. Oh geez, what's going on? Alright, so this is going to block on that because you have nothing. Alright, so something else went wrong. Something's wrong with this loop down here. What did I do? Move for ACK. Swap. Why do you swap? You shouldn't swap. That's my problem. That's might be my only problem. Let's just run it. Got an output error, but things are happening here that look almost right. Cool. Okay, so this looks like it's... Oh, geez, you filled up. Of course. Of course. Okay, so for one thing that needs to happen. So that'll empty. My output's still wrong, but it's different wrong. Why are you not getting as many values as you're supposed to? I'm worried I have a fundamental flaw with what I'm doing with this, but I shouldn't? Alright, so I want to... Why is the 3 working fine, but the 5 not? $17 wants to come over here, so your ACK is 28. Then you want to sub up. So I'm probably just varying the wrong value through here, like the most recent instead of something. Alright, so one thing at a time. Am I doing the stack correctly? 77, 17, 77, 67, 17, 77, 30, 30. Yeah, so this is cycling properly. This is filling and emptying correctly. So this looks like it's going right. Something's wrong with... It seems like you're getting the most recent value when you should be getting the least recent or something. Just on a hunch. This is doing one of those things I described where it's... Oh, geez, no. Not that. Okay. Why? Why is this wrong? Oh boy, I one more leveled pretty hard, didn't I? That first one was so quick. And cool things are happening here. It's just gonna take a little while. Man, today of all days when I have like no recording time. I am eating into my sleep time kinda severely right now. Sorry, future me. Gonna be grumpy in the morning because of this. Okay, so what's going wrong here? What data flows into you? Alright, so you discarded a value. I don't just have these in reverse order. Move ACK down, move ACK left. You received a 0, you received a 0, you subtracted a 0. Great, good for you. Move right nil. Okay, move ACK left. So you're moving a 77 over here. That is definitely not the right value for you to be subtracting. You want to add that one. You already did, so you're at 88. So yeah, that's most recent. This is least recent because it's a LIFO kind of. Well, it is exactly, but now, okay, so why didn't it work to do this? And why is my 3 wrong? You got a 0. How? How did you get a 0? You're subtracting 11. Why? You should be subtracting a 0, but you receive an 11. Why? The very first one out, yes, is the most recent. So no, clearly this was the correct way. Okay, let me work out what went wrong here, because I don't actually understand it yet. Alright, I think I figured it out. The first iteration of this is doing this in the correct order, so the 11 ends up here at the bottom. But in future iterations, I'm inserting it at the other end. So I have my... So I think I can actually get rid of all this synchronization logic, and instead just wait for a signal from this, since I am sending a signal anyway. Have this only do 4 of them. Yeah, okay, so I can... I can have this simply wait for that signal, because I want to do it after all this logic has finished. Just comment out almost all of this. I still want to move the 5, but I don't need any of the synchronization. I do want to jump to loop, though. Okay? How's that look? 11 goes there, 77 goes there. That's not right. Now none of the values are there. Okay, so that's still wrong. Alright, so pretty sure I know how to fix that. I do this. So I discard the value on the other side. That looks better. Hey, look, it's... Ooh. And then maybe this is backward at this point. It's getting better. Well, okay, so if this were backward, then this is not the exactly what would be happening. Hold on, okay, so so you get a 94. That's where it first goes wrong. You should not be subtracting anything yet, so you're subtracting 1 step too early. You have those values. So you already have the 3 values in there. Yeah, so clearly you subtracted the 11 one step earlier than you were supposed to. So this is not working yet. I have like this is one value ahead of where it should be relative to what these expect or something. Something like that. Yeah, so you subtracted the 11. Yeah, okay. So do I actually want 6 values here or what? Move down nil, move left, right. Yeah, it's like I need a 0th iteration of this before I move an actual value into the stack. Because yeah, these are all the last values, and they need to be one more back from this. Yeah, okay. Can I just like let these get ahead of themselves initially somehow? I don't know. Let me think about the best way to solve this. All right, so first way that comes to mind is probably going to be pretty straightforward. Is just to delay the value from this by one step by using your back buffer. So I'm going to do everything else the same, but this initial 0 that's in back becomes the first value from here, essentially, that goes in there. So I just stick you into the back buffer, give the front buffer over here, and that'll delay it by 1, right? And everything will work? Okay. Sweet, I think I did it. Okay, so what do I think of my program? I'm slightly sad that timing logic, I just deleted that portion, that timing logic didn't end up being part of the solution, because I thought it was kind of a cool idea. I did get it to work for what I wanted, it just wasn't the thing that I should have wanted there. I like that I saw the likely interplay between these two, like this as temporary storage while I reshuffle the stack for that. That's cool, that makes a lot of sense. Yeah, I like this program. It's slow, it's a bit unwieldy, it has a lot of instructions, like I have a bunch of unrolled loops in it here and here that I could maybe make more efficient if I wanted to get my instruction count down. As far as cycle count goes, I don't predict I'm going to do too badly. I think I'll be toward the bottom of the upper third of average cycle count. I think I'll be slightly above average on cycle count, but not severely above average. All right, let's go fast and see how it does. My program works. Instruction count is very high. Cycle count is extremely high. Oh, fascinating. There's a quick way to do this that a lot of people did. So I'm at the top. No one else's solution used as many cycles as mine. I am this blip, and that's the solution that I own. Okay, so mine is slow, but it's cool. I like the way it works. 7 nodes, of course. Some people used all 9. Good for them. With the signaling that has to go between these, I have a lot of like linearization. I'm not taking advantage of the parallelism too well here. Okay, this is another one where I'd love to be able to see other people's solutions, because it would be fascinating to see how somebody does this in like in that few cycles. Like there is a extremely faster way to do this somehow. I thought I had, right, so early on I keyed into the idea that I could just subtract a value that was n back for each of these and not have to store all the intermediates, except then I did end up storing all the intermediates. So maybe it would have been a lot faster to just reconstitute this number each time and this number from what I pulled out of there instead of doing the arithmetic on it. That seemed like a good idea at first, but since I ultimately did store all 5 values back, I think it didn't save me anything, and maybe that way of thinking locked me into a way that ended up with my high cycle count. I don't know, like since I am now locked into that way of thinking, like this is just the mental model I've built around this program, I can't see easily over the walls of that mental model to like another potential way of doing it. Anyway, this was awesome. I loved this puzzle. I'm totally okay with my cycle count being high because I think my solution is cool, even though it's slow. So I'm happy with how that went. All right. So cool. Next time, signal divider. Great. Got to deal with division. Sounds good. I'll see you then.